All right, we are in intermediate algebra, and we're on Chapter 2, Section 1, which is actually Learning Plan 1-4 in our course. We are going to be solving linear equations in one variable. This is the meat of algebra, the stuff that makes it fun, right? Okay, first off, we have to know the difference between an expression and an equation. Once we identify linear equations, we're going to test whether a number is a solution. We're going to solve by using addition and multiplication, and then distribute the distributive property. We're going to work with fraction and decimal equations, and then we're going to tell whether there are contradictions or identities. So let's start with the first objective, distinguishing between expressions and equations. I think one of the things that people have a hard time with is they don't know what to do. For instance, 4x plus 8. Well, what am I supposed to do with that? Well, if it's an expression like this you would simplify it. Well, you can't really simplify 4x plus 8, but if it would be 4x plus 8x, that would be 12x. And so that's how you simplify. You make it easier. 4x equals 8. Now it's an equation. What do you do with equations? You solve equations. So it's important to recognize whether you've got an expression or whether you've got an equation, because what you've got helps you know what you're going to do. You simplify expressions, you solve equations. That's what makes something an equation, that equal symbol. An expression doesn't have an equal symbol. So, pretty simple here. Decide whether something is an equation or an expression. In this case, it's an equation because it's got an equal sign. Pretty simple, right? Once you know what to look for, you know what you're going to do. This is an expression because it doesn't have an equal sign. An equation is like an English sentence. The dog ran. That's a sentence, all right? An expression, over my dead body. Yeah, it's a group of words. Yeah, it does mean something, but it doesn't express a complete thought. It doesn't have a subject and a verb. An equation has an equal sign. Okay, so you decide whether these are expressions or equations. The first one here is an expression, and so we would simplify it. How do you know? Well, it doesn't have an equal sign. The second one does have an equal sign, so it is an equation, and we can solve equations. Okay, so once we've got an equation, what are we going to do? Well, the first thing we're going to do is to test whether an answer solves that linear equation. What makes something a linear equation? Well, it's got a variable, x, and a and b and c are any real numbers. So it could be 3x plus 4 equals 7, or it could be 2x minus 2 equals 4. I don't know. I was just making those up. But the important thing is that these are the letter A, these are the letter B, and these are the letter C, some real numbers. It's a first degree equation because the x is to the first power. Actually, if we don't have a power written up here, we assume it's the first degree. Okay, so once we know that we've got an equation, then we know that we can solve it. An equation is solved by finding its solution set, or all the numbers that solve that equation. We do it by making equivalent equations, ones that have the same solution set. Here's an example of an equation. Notice it's got an equal sign. Negative 8x equals negative 128. Does 16 make that true? In other words, if we take 8 times 16, do we get negative 128? Sure, you do. And so 16 is the solution, or we would write x equals 16. We're going to solve equations by using the addition, multiplication properties of equality. In other words, you can add the same number to each side, or you can multiply each side by the same number to get equivalent equations. Why would we want to do that? Well, it's pretty simple. If we have a situation like this, we want to solve this system of equations. Or I'm sorry, this equation. How do we go about doing it? Well, the first thing we notice is we've got like terms that we're going to want to combine. So let's rewrite this. 4x plus 8x is 12x equals 17x, and then negative 9 minus 1 more is negative 10. Now we've got all our like terms combined. It's time to get all the x's on one side of the equation. I think probably the easiest thing to do would be to subtract 17x from each side. In other words, we're using the addition property. Why? Well, because we added negative 17 to each side. When we do, the 17's cancel over there, and we get 12 minus 17 is negative 5x equals negative 10. Now we're going to use the multiplication property and divide each side by negative 5, and we get x equals 2. Let's check to make sure that's true. 4 times 2 plus 8 times 2, do we get negative 9 plus 17 times 2 minus 1? Well, let's see what we get. I'm going to change colors here. Getting a little crowded in my red category, isn't it? 4 times 2 is 8, plus 8 times 2 is 16. Do we get negative 9 plus 34 minus 1? 8 and 16 is 24. Negative 9 plus 34 is 25 minus 1 is 24. So our solution checks. Let's go on. You solve this one, and when you're done, I'll show you how I did it. Okay, I don't have any like terms to combine on each side, but I can start with 15t minus 10. I can subtract 15t from each side by using the addition property, and I get 23 minus 15 is 8t minus 16 equals negative 10. I'm going to add 16 to each side. My goal is to get the t all alone. So 8t, those cancel, equals 6. Now I'm going to use the multiplication property, divide each side by 8, and I get t equals 3/4. Let's check it and see. I'm going to change colors here. 23 times 3/4 minus 16. Do I get 15 times 3/4 minus 10? 23 times 3/4 is 69/4 minus 64/4, because that's what 16 is. That's 5/4. 15 times 3/4 is 45/4 minus 40/4 is 5/4, and so I get 5/4 equal to 5/4. My answer is t equals 3/4. So the way we go about solving problems is the first step, we get rid of fractions and decimals, which we haven't seen any yet, but I'll show you how to do that. Then we simplify each side using the distributive property. Then we isolate the variable. Your mission, should you choose to accept it, is to isolate the variable. First by using addition, and then by using multiplication. And finally, we check to make sure that our answer makes sense. So, let's solve linear equations using the distributive property. Here we go. Step 1, clear the fractions. Don't have to worry about that. Let's go right on to step 2. Use the distributive property. 6, and we're going to distribute the negative sign into both parts in parentheses. So minus 4 minus x. Make sure you make that minus x equals 8x. Negative 2 times 3 is negative 6x. Negative 2 times 5 is negative 10. Now let's, step 2, combine like terms. Well, we've got 6 minus 4 is 2 minus x equals 8x minus 6x is 2x minus 10. Let's add x to both sides, and we get 2 equals 3x minus 10. Then let's add 10 to both sides, and we get 3x equals 12. Let's use our multiplication property, divide both sides by 3, and we get x equals 4. Put a 4 in here, put a 4 in here, and put a 4 in here. Let's change colors so that we can see what we're doing here. 6 minus 4 and 4 is 8. Does that equal 8 times 4 is 32 minus 3 times 4 is 12 and 5 is 17 times 2. 6 minus 8 is negative 2. 32 minus 34 is negative 2. So we do solve that equation. Okay, let's go on. Let's see what we got here. Oops. You do this one, and while you're doing it, when you're ready, I'll show you how I did it. Okay, the first thing we're supposed to use is the distributive property, so we're going to distribute the 12 into the 6 and the 2. Okay, 12 times 6 is 72c. 12 times 2 is minus, notice the negative sign, 24. Don't have any simplifying to do over here. So now it's time to add to get everything on the same side. I just like to add the smaller number to each side. In this case, subtract 5c from each side. So I get 67c minus 24 equals negative 8. Add 24 to both sides. We get 67c equals 16. Divide both sides by 67. C equals 16 over 67. Let's check and make sure we got the right answer, or we got it right.